this is the most common topology of the two-stage op-amp, where you have a single stage op-amp in the first stage. This is the single stage op-amp we discussed earlier. And the second stage is a common source amplifier. And let us denote the bias current in the first stage by I naught and maybe the second stage by I5 to say that that is the current that flows in the transistor M5. Okay. And as we saw last time, those are the plus and minus input terminals of the op amp, and that is the output terminal. Okay. So, the picture of our op amp looks like this. And that is the output, and we can use it in any way we want. Okay. So, we can quickly evaluate all of the routine properties of this. The DC gain we already saw, it is the product of the DC gain of the first stage and the second stage. Okay. Then what is the output resistance of this op amp, that is in open loop? What is the output resistance? 0. Why? Infinity if the transistors have infinite output resistance, that is if lambdas are 0. What if lambdas are non-zero? So, I am looking for the output resistance between this terminal and ground. So, what is that? 1 by GDS. Which GDSs do come into play here? 5 and 6, okay, both, because we have this common source amplifier that contributes GDS 5 across it, and this current source contributes GDS 6. Okay. In fact, that is the reason why we have GDS 5 plus GDS 6 in the denominator over there. So, the output resistance is 1 by GDS 5 plus GDS 6. Okay. So, the output resistance is kind of high, it still does not look like a nice voltage source. Okay. So, but of course, one of the important things is the op amp is always used in a closed loop with negative feedback. Okay. So, what matters in an application is how much the closed loop output resistance is, not how much the open loop output resistance is. Okay. Because if you have a very high gain in the op amp, then it does not matter what the open loop output resistance is, the closed loop one will be very small. Okay. The next tutorial, which is already posted, has some problems related to this. Now, if you do want to further reduce the output resistance, what can you do? What are the possibilities? Let us say I want I am okay with the gain that this gives me. This is of the order of the product of two MOSFET gains, right. That is, if a MOSFET's gain, inherent gain has some value, this is like the square of that. So, if I want to further lower the output resistance, but I do not particularly care for increasing the gain, what is a solution? Voltage source, source follower, we have to buffer this, right. So, just like we buffered the single stage op amp, we can also further buffer a two stage op amp, then we will get a high gain as well as a small open loop output resistance. Okay. So, that is possible. So, you can also follow this up with a buffer. Now, again what happens is when you use source follower buffers, the output swing is sort of limited. Okay. So, that is why when you have very low supply voltages, you tend not to use them, but if you have a reasonably high supply voltage, you can use source follower buffers. Okay.